Greetings and welcome once again to my new calculus channel. My name is John Gabriel. So, a little out of breath this morning, so I'm talking slower than I normally would. This video is going to talk about how to solve word problems, and I'm going to be focusing on 7th grade because really I think a lot of students go off the rails even as early as 7th grade. In fact, a lot earlier, but 7th grade is when they really just begin to hate math. And what I did was I did a search and I picked out the site here, North and South Esk Regional High School. Went to their webpage and I looked at some of their word problems, and probably the most challenging was 6 and 7. And of course, they give little tips here as to what the competency is, but of course, it's not really, they're not good tips, and they don't really help the student in any way whatsoever, because first of all, students don't really understand division, just like their teachers don't. Okay, so division is an arithmetic measure. And in fact, even when you count, you're dividing. When you say 1, 2, 3, 4, 5, etc., you're dividing. Okay, and in my free ebook, which is called Learning the Correct Way, you'll learn why what I'm telling you is true and why you've never known about it. So, I'm going to show you now how an AI solves these problems, and I'm going to show you how to improve on those solutions and teach you why you do the things that you do. Because the AI is probably going to do what your teachers and math professors do, which is generally not the correct way. Okay, so let's go to the beginning. So what I did was I went to ChatGPT and I said, train A arrives every 18 minutes. I stated the problem and I asked it to solve it. So it says to find the previous time, train A and train B arrive together. Let's just get rid of that. Train A and train B arrive together before 6:45 p.m. and we need to determine the least common multiple. So it doesn't tell you why it must determine the least common multiple, and it just goes ahead and shows you how to factor out in terms of the prime factorization theorem or the unique theorem, which is the fundamental theorem of arithmetic. It's called by those two names. And then it gives you 54 minutes as the LCM, then it tells you to subtract, and that's your final answer. But looking at that, you don't really understand why the problem's solved that way. I'm going to show you now how to do it correctly. I also asked you to solve the second one, and I also corrected the second one is this one here. At a restaurant, one table with 5 people has a $19 bill, and another table with 6 people has a $23 bill. Find out which has the least cost. And I also correct that. But now, first of all, what I do is I say critique of your first problem. You don't explain why the approach works. All you do is take the LCM. And I mean, students don't really know what on earth an LCM is. Anyway, they never understand it. And not even their professors and math teachers understand it because they don't understand arithmetic or the foundations of arithmetic, which, by the way, came long before numbers. Okay, long before numbers. What does an LCM tell one in general? What does an LCM tell one? Okay, yes, yeah, you can give me the answer. You can say, oh, yeah, it's a prime factorization. Big deal. Even a computer can do that. In this case, the LCM tells us the least time duration that is measured by 18 and 27. Okay, tells us the least time duration. Because division is a measuring process, the prime measuring process, and you will see links in the detailed section of my video which you need, whether you're a math professor or a high school student, you absolutely 100% need to download and study, not once, not twice, but several times. You need to study it more if you're a PhD in mathematics because you're probably more ignorant than a high school student. So ultimately, the problem boils down to finding the least time and why the least time duration. So one can eliminate an event where the trains arrive simultaneously more than once. Okay. Then by the same idea, one can find what time or future times they arrive together. So there's a lot of simple information in a problem like this, and I allow ChatGPT to respond. It says, "Thank you for your critique. It is accurate and well structured, and you're correct." Blah blah blah. And it says, particularly in terms of measurement and the nature of division as a fundamental arithmetic process. Your point that division is a measuring process, the prime one is foundational, fundamental. In this context, the arrival intervals 18 and 27 measure durations. Okay, the LCM identifies the least duration that these two divide, meaning it is the least common measure of time that contains both intervals. Look at this. That contains both intervals without remainder. In other words, it divides the least time interval exactly. Okay, something which morons like Jean-Pierre Massager or the fools on Sci.Math, Marcus Clives, etc., don't understand. They don't know what a factor is. So this least duration, 54 minutes, is the first and smallest common multiple of both periodic events, excluding trivial zero. Well, zero is not even a number. But it represents the first point in time when both trains align again. So the reason for choosing the LCM is not merely procedural, which is really all that the first solution shows, but ontological. You need to look up that word, by the way. It's an important word, ontological. It gives the minimal time duration that accommodates both train schedules without remainder. Without remainder, the smallest interval measurable by both. So furthermore, your comment about eliminating extraneous simultaneous arrivals is key. Okay, so in other words, somebody could sit down and sort of just go back and subtract 18 or 27 and end up at a number that might contain more than one time interval if they're doing it that way. Okay, so the LCM identifies the unique least prior or next time when both events align, excluding multiple zero. And that's essential for solving the problem once and only once. No ambiguity, no overcounting. You solve it right the first time, every time. And then it says, would you like the solution rewritten with this conceptual framing? And I said, yes, and it does. It does a pretty good job of it. Okay. So it says division is a measuring. We seek a duration that is measured exactly by both 18 and 27, and this guarantees the duration contains an integer number of arrivals for each train. Okay, and so it finishes off beautifully and says, okay, this is the most recent time, 5:51, that both trains arrive together before 6:45. And in fact, we could calculate as many times before that time that they arrive together and as many times after by simply knowing the least time duration. Okay, and then for the second problem, I said you're finding level magnitude. It's also known erroneously as an arithmetic mean in the mainstream. But an arithmetic mean has nothing to do with the middle of anything or relative position. So Wikipedia entry is wrong. Your math professor is wrong. He's an idiot, just like your math teacher is an idiot. So you're finding the level magnitude for what is paid at each table. This explains why you measure dollars using number of people as a measuring unit. That's ultimately very important. That's what you're doing when you're calculating the cost per table. Okay, so if you say there are 5 people at table 1 and you paid $19, then you're measuring the $19 with 5 people as the measuring unit. Okay, so obviously the result will be that the least cost will be the smaller level magnitude or arithmetic mean of the two, not of the troll, of the two. I wanted to carry on typing, but I pressed some button and it doesn't really matter because ChatGPT got the gist of it. So it says correct. You've distilled the second problem to its essence. The goal is to compare the arithmetic means of the cost per person at the two tables. So now it's not as these fools say, it's just division. It's not just division. There's a lot more involved there. Every number, by the way, is also an arithmetic mean, or rather a level magnitude. Every number. And when you perform division, you're performing measure. It's literally like taking a measuring tape and measuring something. And it doesn't have to be the same. In fact, it's usually not the same type of magnitude. For example, in this case, the one magnitude is dollars and the other one is people. But we're not using the magnitudes, we're using the number abstractions, 19 and 6. Okay, listen, I'm a genius. Most of you are morons, so pay careful attention. If you're a professor, sit up straight, you fucking idiot. I have a special disdain for you. A special disdain for you. You arrogant nincompoop. Right. Now, um, let's see what the conceptual explanation is. Each group decides to split the bill equally, meaning we're looking for a level share among individuals at each table. This is a classic case of measuring one magnitude using another. So division here is used to measure dollars by persons. See, even ChatGPT doesn't understand it, but can come to the right conclusion. This yields the cost per person. Okay, in other words, the level measure or the level share of the cost distribution in terms of magnitude. The bill is the total magnitude being measured, and the number of people is the measuring unit. And of course, the quotient is not the uniform share, but the uniform measure. Okay, so even ChatGPT is infected with the utter drivel of share. You're not sharing when you divide because, for example, how do you share 1 by 2051 over 6 or something like that? It's very hard to do that, right? So everything that is in a mainstream academic's mind is usually utter drivel. It's a sewer. They've got syphilitic brains. They're incompetently arrogant, stupid, and beyond correction. So the table with the smaller arithmetic mean reflects the lesser level cost per person. Okay, and that's the solution. And so here we have it. 19 divided by 5 gives us a level measure of 3.8. And 23 divided by 6, 3.833. Since this one is less, it means the table 1 had a lower cost. Okay, so the level magnitude, or the mean for table 1, is lower. If you're not already subscribed to my channel, become a subscriber, follow me on Academia.edu, and also become a member of my members only channel. I am working on a series on Archimedes and his works, his famous works, the works of Archimedes. I'm going very slow. To be honest, I don't know when the next video is going to come out, but you can still support me because you're learning a lot from me. In fact, if you're honest with yourself, you've learned more from me than you've ever learned in your entire school or university education. And what have you contributed as a return in thanks to me? Do you know that I am living under the poverty level because of bastards like mainstream professors and teachers who've libeled me and have attacked everything I've said and have basically gone to every conceivable length to destroy what I'm trying to teach you, which is the right way. Okay, I do know the right way. The rest of the world does not, but I do. That's not narcissism, you morons. That's confidence. That's fact. If you can refute anything I say, say it. Otherwise, shut the fuck up. Okay? Don't open your mouths. Plug your asses and your mouths. I am the great John Gabriel, and this is the New Calculus channel. Till next time.